So in this video, we'll talk about problems 6 through 10. They're from the 2015 Keystone scoring sampler. They were in Module 1 and they're all multiple choice questions. These problems actually appeared on the 2014 Keystone test. So if we dive right in here, problem number 6 tells us that one of the steps someone used to correctly solve an equation is shown right here. So we started with this equation. It looks like they've gotten rid of the parentheses when we went from this line to this line, so it seems like they've pop that 3 into the parentheses. If you look at what they've asked us to try and decide, which statements describe the procedure that we see being used in order to solve the equation and identify the property that justifies the procedure. Now, I look at choices A and B, and it talks about adding 3 and x. I didn't add 3 and x right here. This is 3 times x. So there's no way that I'm adding 3 and x to eliminate the parentheses. I can get rid of A and B right away. Now if you look at choice C, it says that he multiplied x and 7 by 3 to eliminate the parentheses. Makes sense, yeah. He multiplied the x by the 3, he multiplied the 7 by the 3, that turned into a 21. That seems good. But then it says this procedure is justified by the associative property. Well, anytime we push a number that's multiplying parentheses into the parentheses, we're distributing it in. The distributive property is what's being used. So the reason why we rule out part C is because they've referenced the wrong property. So we know we're multiplying x and 7 by the 3 to get rid of the parentheses, and that's of course the distributive property. So hopefully that one you realize isn't too bad. Now if you check out number 7, 7 is a lot tougher than the one that we just talked about. So it talks about Raul having saved $640, Jamie has $320 saved. They each begin a new job on the same day and they save all of their money. Tells us how much Raul earns each day, $180 per day, and then Jamie earns $200 per day. And how many days will they have an equal amount of money? So every cent that they make, they're saving. So since Jamie is earning $200 a day and Raul is only earning $180 a day, Jamie is going to be having his savings grow and eventually catch and pass Raul's since he's making more money every single day. We want to figure out how many days is going to go by until they have exactly the same amount of money. So I could do this with guess and check. I could try to do this with the calculator and kind of keep everything organized within a table. That will work, and if you can't figure out any other way to do this problem, go for it. That's going to get you the right answer. I guess another option that you have here, since it's multiple choice, you could try to figure out how much each person's going to have after these number of days, and if they have the same exact amount after plugging in these values, you're going to realize that that's your answer. The approach that I chose to go with, though, is I thought about Raul, and I realized, hey, it tells us the rate that he's earning money is $180 per day, and he begins with $640 saved. So what I thought is it makes sense to build a slope-intercept equation for Raul. Here's the rate that I put in place of M in slope-intercept form. Here's the beginning amount that he had saved that I put in place of B. And so X is going to be the number of days that he works, and then Y is going to be the amount of money that's saved after working for that many days. I did the same thing for Jamie, right? The rate that he's earning money is $200 per day. So that went in place of M in Y equals MX plus B. And then the beginning amount that he had saved was $320. And so that's what I put in for B. I realized, hey, I've got these two equations, Y equals 180X plus 640 for Raul, and Y equals 200X plus 320 for Jamie. I want to know when these equations equal each other. When's the amount of money going to be exactly the same? I wanted to solve this system of equations that I wrote out here. This second equation tells me that y is equal to what I boxed up right here. And so I thought the method that makes sense to use to solve the system with was substitution. So I substituted what's in this box, what y is equal to from the second equation, in for the y in that first equation. So when I copied out that first equation, I had what's in this box replacing the y. Then I had the equal sign next. And then I had the same exact thing that was already on the other side of the equal sign appear on the right side of it on this new line. I then said, all right, well, I want to solve this equation for x. So I need to get all my x's together. I chose to move these 180x's over with the 200x's. So I subtracted 180x from each side. 200x minus 180x is down to 20x. I want to solve for x. So I've got to move this plus 320, subtract 320 from both sides. Then it said 20x is equal to 320, right? 640 minus 320 is actually 320 again. And then if I undo this multiplication by dividing both sides by 20, 320 divided by 20 is 16, and we are looking at choice B. In number 8, it talks about a compound inequality. And a compound inequality is any inequality that involves the word and or the word or. The word that this compound inequality involves is definitely and. When we talked about compound inequalities earlier in the year, I always wrote out the word sandwich, and I emphasized the second, third, and fourth letters of that word. And anytime we have a sandwich inequality, we should be able to represent that as a sandwich graph. What do we mean by sandwich graph? Well, this is not a sandwich graph. Here's a point that's plotted. Here's a point that's plotted. We didn't have the shading sandwiched between those. We had it working outward each direction. So we can rule out choice A. We can rule out choice B. Those are not sandwich graphs. But then check out choice C. Choice C, we've got the 2 points plotted, and the shading is sandwiched between those 2 points. And choice D has the same characteristic. 2 points plotted, shading is sandwiched between. So I guess the distinction that we have to make is whether or not we need to have closed circles as the endpoints or open circles as the endpoints. Well, think about what we've done in order to decide that over the course of the year. This says x is less than or equal to -3. That means x is allowed to equal -3. We're allowed to include I think I said negative a couple times there. My fault. X is less than or equal to 3. X is allowed to equal +3. Therefore, we're allowed to include +3 on our graph, and we denote that on the graph by filling in that circle. Similarly, x is allowed to equal 0 because of this little piece of that inequality, and therefore we want to include 0, fill in that circle. We don't want open circles. We're ruling out choice D, and our answer for this one is definitely going to be choice C. Problem number 9, a little story problem here. So someone keeps apples in 3 bins and 2 crates in her store. Tells us that each bin can hold no more than 200 pounds. Each crate can hold no more than 50 pounds. Which graph represents all the possible weights in pounds of apples that Patricia can keep in her store? So what I thought here is it makes sense to kind of do this problem in 2 separate ways. I want to do a little calculation involving the bins, and I want to do a little calculation involving the crates. So I highlighted my information about the bins in yellow and my information about the crates in green. What's the most weight that we can fit into these 3 bins? Well, if each bin can hold no more than 200 pounds, the amount of weight that can fit into those bins is the number of bins we have times the most weight that a bin can hold. So that's 600 pounds. What about the crates? Well, we've got 2 of those crates, and each crate can hold no more than 50 pounds. So a crate can hold exactly 50 pounds, but nothing above that. So what's the most weight that can fit into the crates? 2 times 50. Or 100. So the total weight of apples that she can store in these 3 bins and 2 crates is 600 plus 100. No more than 700 pounds of apples can be stored in these 3 bins and these 2 crates. So no more than 700 pounds. That means I don't want anything above 700 to be shaded on my number line. So that allows me to rule out choices C and D. I can have the bins not totally full, so I can have under 700 total pounds, but I definitely can't exceed 700 pounds. And once again, what we see is we have to decide between A and B by trying to pick whether or not we want to include 700. And the phrasing within the problem that's going to allow us to decide what the answer to that question is these 2 words, no more than, actually 3 words, no more than. If I have no more than $20 in my pocket, I can have $17, I can have $18, I can have $19, I can have $20. So I can equal $20 in my pocket, but I can't have $20 and 1 penny. So I am, when I see no more than, I am allowed to equal the number that's at the top. And because of that, we want to include 700. And since we want to include 700, we want to have a filled in circle there. So this is going to be the choice that we go with. And then the last question in this list, another inequality problem here. So nitrogen is a gas at certain temperatures under normal conditions. The temperature's T in degrees Celsius that are represented by this inequality right here. So T is, and I looked at that symbol and I realized it's greater than or equal to, so T is greater than or equal to negative 196, which best describes the meaning of the inequality. Well, if T has to be greater than or equal to, I know that I don't want to pick something that's below negative 196. So I eliminated choices A and C right away. If you look at B, nitrogen is a gas only if the temperature is above negative 196. Nitrogen is a gas if the temperature is at or above negative 196. The last three problems that we've done, every inequality problem that we've discussed within this video, has amounted to looking at whether or not we're allowed to equal something. T is allowed to equal negative 196 and nitrogen is still a gas. So nitrogen is a gas only if the temperature is at, right, equal to, or above negative 196. This is close to being correct. The only thing that choice B doesn't account for is that nitrogen is still a gas if T is equal to negative 196, which is why we're going with choice C. Being at negative 196 is equal to it, therefore that's why we're picking D.